Recording. Okay. Okay, so recorded, so time to start. Okay, so this is the final chapter before your end of year exam. So we are gonna do on this topic called redox. So redox represents oxidation and reduction. So why redox? Because RED from the reduction, OX from the oxidation. Okay, so what is this last topic about? So do take note, redox is a reaction. Okay, it's a reaction. So we got redox reaction. That's one of the reaction. There's other reactions that you've actually covered as well. The next one is actually neutralization reaction. So they are not the same. So if I say it's a redox reaction, it means it's a redox reaction. It is not a neutralization reaction. Okay, so I got redox reaction, neutralization reaction. The third type of reaction that you have also learned is the precipitation reaction. So all these three reactions are distinct. Okay, are distinct. Okay, meaning that if it's a redox reaction, it won't be neutralization, it will not be precipitation. If it's precipitation, then it will not be neutralization, it will not be redox. So in your syllabus, it is quite distinct. These are the three main reactions that you will need to know. Okay, and redox is the one that we're going to be covering for today. Okay, thumbs up if all is okay for now. Thumbs up. Okay, good. Okay, so we're going to cover redox reaction. We have covered neutralization precipitation. Now we're going to go on to highlight that really in this particular chapter, what do you need to know? Okay, let me repeat again. In this particular chapter, what do you need to know? So what you need to know, actually there's only three main things. So first one is to be able to identify redox reaction. Okay, and there are four ways to be able to identify them. Okay, there are four ways. Okay, so I put here four ways or four methods. Next, other than identifying, you need to be able to explain, okay, the redox reaction. Explain, let me rewrite. So you need to explain why is it a redox reaction. Explain why it is redox. Okay, so if you can do number one, you can do number two, then you're actually almost like 80% done in this chapter already. Okay, the last one is to be able to identify and explain oxidizing agent and reducing agent. So there are these three main segments, okay, in this particular chapter. We will spend most of our time covering the first one and the second one. The third one will actually be at the very end, okay, after we have covered number one and number two. Okay, so let's start. So when you do rust, when it's rusting or when it's cooking or when there's fireworks, in general, all these are actually redox reaction. Okay, all these are actually redox reaction. So a lot of things around us actually undergo redox reaction. Okay, so when your rain make the bicycle rusty, the fireworks, the barbecue, all this redox reaction is actually happening. So let us zoom in now in terms of redox. Okay, so if you look at the learning objectives, first thing is to define and identify the four different ways. We're gonna look at gain and loss. So gain or loss of oxygen, hydrogen, electrons, and the last one, oxidation state. Can you put a star for oxidation state? Because oxidation state is one of the most important one. Okay, this is the one that will commonly be tested. Commonly be tested. Oxygen, hydrogen, these two seldom are being tested because it is too easy. Okay, the main one will be oxidation method. Electrons sometimes. Okay, sometimes will be tested. So learning how to identify and define these four different ways. Okay, that's one. Secondly, is being able to identify and explain your redox reaction. Okay, now, so when you look at explaining and identifying redox reaction, I just want you to put a star here. I want you to put a star there. Oops, sorry. Put a star here and write down template to explain redox. So there is a standard way. Okay, I say again, there is a standard way to explain redox reaction. We are going to use this template to explain redox reaction. Okay? And the last one, we look at the lab test. The lab test is really looking at the oxidizing agent. And we're going to look at the reducing agent. Okay, now, so I'm going to write down here OS. OS stands for oxidizing, OA, oxidizing agent. RA for reducing agent. Now, just going to be writing it here now. Under OA, you're going to learn one main one, which is potassium manganate 7. Okay, the oxidizing agent you're going to learn is potassium manganate 7, KMnO4. We're going to cover it later on. In terms of reducing agent, we're going to learn using potassium iodide, Ki. Okay, now, these two are the main two oxidizing agent, but I want to add in some. So these are this is the chemical, but there's some things that you need to add on instead of just writing the chemicals down. So generally, whenever you see potassium manganate 7, it will always have these two terms. It will say that it is acidified, and then they will mention the word solution. Okay, so the word acidified and solution. Sorry, let me back the thing again. Okay, the word acidified and the word solution, they are important. In terms of potassium iodide, you're actually using potassium iodide solution or aqueous potassium iodide. So it's either you say the word aqueous or either you say the word solution. Because aqueous just means dissolve in water, solution actually just means dissolve in water as well. Okay, so we're going to cover 1, 2, 3 for today, and let's start. Okay, so first definition in terms of redox. We're going to look at in terms of, so you're going to see how I'm going to mention reduction and oxidation. So we're going to highlight how do you identify oxidation, how do you identify reduction. So in this case here, okay, we're going to highlight the first thing, which is oxidation is the gain of electrons. So when an element or when a substance gain electrons, substance gain electron, not why, sorry, when. Okay, when a substance or element gain electron, this is okay. Sorry, gain oxygen. This is oxidation. Okay, so oxidation defined by gain of oxygen by a substance. So example is rusting. So what happens is that the iron metal become iron trioxide. Okay, how did the iron become iron trioxide? Because the iron gained oxygen. That's why it became iron trioxide. So we say that the iron atom or the iron has been oxidized. Now this is the equation. Do take note. Don't need to memorize. Don't need to memorize this. So this is an equation that you don't need to memorize. Okay. Now this is the start of one of your standard template statement. Okay. So how do you write in terms of oxidation, explaining why or what has been oxidized? So in this case here, you know that iron has been oxidized because iron gained oxygen, right? So I'm going to say that the chemical symbol, so Fe, gains oxygen to become Fe2O3 dot XH2O. Okay, so I'm going to say that the Fe gains oxygen atoms to become Fe2O3 dot XH2O. This XH2O just means water attached to it, okay? Water attached to it. So the key idea here is that the Fe became Fe2O3. The water there is because it's part of the hydrated part to it. Okay. Hence, we say that iron Fe is oxidized. Okay. So Fe gains oxygen atoms to become Fe2O3. So that's why Fe is oxidized. So realize I write the chemical symbol of the thing that has been oxidized. Okay, we're gonna go through a few more examples later on. You'll get a sense of this particular statement a bit more. Okay, so oxidation, first thing is the gain of oxygen. Okay, next, we're gonna go on next to reduction now in terms of oxygen. So once again, we're looking at definition 1b, it's about oxygen still. So reduction is the loss of oxygen. Okay, so reduction is the opposite of oxidation. And hence, if oxidation is the gain of oxygen, reduction will be the loss of oxygen. Okay, so we're going to look at this particular statement here. Iron can be obtained from iron 3 oxide in a blast furnace. Carbon monoxide removes the oxygen from the iron 3 oxide, reducing it to pure iron. So what we lost oxygen atom? So Fe2O3, which is the iron 3 oxide, okay, lost oxygen to become iron, Fe. So actually write down this equation over here. Fe2O3 plus CO gives me Fe plus CO2. Okay, so we need to balance this equation here. So it will be 3, 2, 2. Okay, so you can see here that the Fe2O3 became Fe, it lost oxygen. Therefore, it is reduced. Okay, so Fe2O3 is reduced. So the thing that lost oxygen is the thing that's being reduced. Okay. So far, if all okay, thumbs up. Okay. So we go through the first one already. So in terms of the first one, let's recap the first one. So in terms of oxidation, it is the gain of oxygen. In terms of reduction, it is about the loss of oxygen. Okay. So that's the first one that we went through. Let's go on to the next one. Now we're gonna look at in terms of hydrogen. Right? So hydrogen, in this case here, oxidation is the loss of hydrogen. So if I say something is oxidized, it would have lost hydrogen. In terms of reduction, it would have gained hydrogen. Okay, so let's look at this particular thing here. So realize carbon, CH4, sorry, methane here, became the carbon CH4, the carbons that initially attached to 4H. After that, it became CO2. So what you realize is that it has lost hydrogen. So methane, the CH4, lost hydrogen atoms to become CO2. So CH4 is the substance CH4 is oxidized. Okay. Next one, what you realize that oxygen is the other reactant. Hydrogen, so oxygen actually gain hydrogen to become water. Okay, to become water over here. So if we gain hydrogen, therefore this is a reduction. So loss of hydrogen, oxidized, gain hydrogen, this is reduced. So in this case here, we say that O2 gain hydrogen atoms to become H2O. Therefore, O2 is reduced. Okay. Now, I want to make a very distinct thing over here. Okay. I want to let you know that, please, can you see this 2 and this 2 over here? I did not write down inside any part of this. Okay. the ratio or the balancing number does not go into the explanation. So I want to put the star here. Okay, the balancing number, balancing slash ratio number does not, okay, does not go into the explanation. Okay, this is a very common mistake many students will always make. They will always write down the balancing number in, then they actually get it wrong already. So I show you what they write. So I'm going to use green, which is wrong. Okay, so what they wrote here is 2O2 become 2H2O, so 2O2 is reduced. This 2 is wrong. 2 cannot write wrong, wrong, wrong. Okay, so just take note wrong. So cannot write down the 2 over there. So cancel, cancel, cancel. But this is a very common mistake. I am quite certain some of you now listen to this carefully. You're going to write down this ratio number inside the explanation. Okay? But just take note, you're not supposed to write it down. Okay? So in this case here, we went through another definition already. So first one was on oxygen. Now next one is on hydrogen, where we mentioned oxidation is loss of hydrogen. Reduction is the gain of hydrogen. Okay? So just a wrap up in terms of oxygen. So reduction, oxidation. So if oxygen to be reduced, what happens is that it's a loss of oxygen. For oxidation, it's a gain of oxygen. Okay, that's the first one that we went through, the first definition. Second definition we went through was on hydrogen, where reduction is about the gain of hydrogen, where oxidation is the loss of hydrogen. Okay? You realize I'll keep writing this table down because this is something I want you to just take note of and get into your mind. Okay? Knowing when is it the loss of that particular element that can be considered reduction, when is it considered oxidation. Okay, next. Now, electrons. Now, electrons, there's a way to remember it. So for electrons, the acronym they use is oil-rich. So oxidation is loss of electron. Oil, rich reduction is gain of electrons. So OIL, oil, rich, RIG. Okay, in terms of electrons. So oxidation is loss of electrons. Reduction is gain of electrons. So this definition, I just want to highlight, works for all redox, even for those that does not have oxidation of hydrogen. So you realize the first two definitions got flawed, and there's an issue with the first two reactions, because what if there's a reaction that doesn't have hydrogen involved, doesn't have oxygen involved? Then can we use the first two definition? Answer is no lah. And hence we will need to use the third and the fourth one. The third one is on about electrons. Okay, oil-rich, oxidation is loss of electrons, reduction is gain of electrons. So let's look at this one over here. So oxidation is loss of electrons. Let's see how it looks. So when an atom loses electrons, its charge becomes more positive. This is oxidation. So more positively charged. Okay, this actually tells you that is oxidation. Because how did it become more positively charged? Because there's loss of electrons. Okay, so an example, an iron atom lose 3 electrons to become iron 3 ion. So this can be shown here. So you can see iron became Fe3, Fe became Fe3 plus. Okay, so when Fe became Fe3 plus, you realize that 3 electrons is lost here. Now, in equation, we don't have minus, we only put plus. So some students say, sure, isn't it Fe minus 3 electron give me Fe3 plus? Now, we don't write minus in equations. So therefore, in order to remove this minus, I will shift it over, and hence that's what we got over here. So all equations is always plus. There's no minuses. Okay, there's no minus. Okay, so let's look at in terms of explanation over here. Explanation. So what has been oxidized? The Fe has been oxidized to an Fe3 plus ion by losing 3 electrons. Okay, now some students are able to explain that electrons are lost, but they didn't get full marks in whenever exam question comes is because they tend to forget the number. So they're not specific in the number of electrons lost, and hence they get their marks deducted. So whenever you are able to be specific, if you can tell me lose 2 electrons, then please tell me 2 electrons. 1 electron, say 1 electron. Don't just say lose electrons, full stop. Okay, tell me how many electrons it has lost. Okay, so first definition we have gone through already. First part of electrons we have gone through, which is oxidation is about the loss of electrons. So this is the oil. Okay, oil. Okay, next one we're gonna look at is gain of electrons. So reduction is the gain of electrons. So RIG, R-I-G. Okay, RIG. So when atom gains electrons, its charge become more negative. This is reduction. So if you scroll back up here, I wrote here more positive charge is oxidation. Now I'm gonna write here more negative charge, or you can think of it as less positive charge. So something that's more negative can also be something that's less negative. So in this case here, this will be reduction. Why is this considered reduction? Because there's a gain of electrons. Okay, gain of electrons. So in the rusting process, the oxygen molecule gain electrons from the iron. So you can see here, O2, this is the oxygen molecule. It gains electrons to become O2 minus. Okay, so what I'm going to write here, so see me elaborate. So in this case here, O2 has been reduced to O2 minus by gaining. Do you realize here, how come I never write electrons? So actually what's happening here is this. Okay, if you want to rephrase this, it will be that O2 has been reduced to O2 minus. Now, do you realize this is O2? Hence, I'm going to say each O in O2, each of the oxygen in O2 gained 2 electrons to form my O2 minus. So I will be quite specific in a sense. I'll highlight that it is each of the O in the O2. Right? Because if you say O gains 2 electrons, then my question is, or if you write O2 gain 4 electrons, then how is the electron split? Or like, how specific can you get there? So I'll rather that you will take note of this one over here. Actually, first sentence is important because it's telling me what is reduced. Second sentence is important because you tell me how many electrons are being transferred. Or how many electrons are being gained for the reduction to occur. Okay? So this is the third one here, which is RIG. So this one, okay, let's once again at this bottom here, let's think in terms of reduction, in terms of oxidation. So first definition we've gone through is in terms of oxygen, we can tell if something is reduced or oxidized. So to be reduced, something must have lost oxygen. So as I'm going through this part, try to recap, try to recall, okay, how to define in terms of oxygen for redox. So if something is oxidized, they must have gained oxygen. Okay, so that's the first one that we went through, oxygen. Second one we went through was in terms of hydrogen. For something to be reduced, they must have gained hydrogen. For them to be oxidized, they must have lost hydrogen. Okay, third one is in terms of electrons. So something is reduced in terms of it. So you think oil rig. Oil is oxidation is loss of electron. Reduction is gain of electrons. Okay. So we have gone through these 3 different definitions now. Okay. These 3 are easier. That's why I went through like a breeze. The main one that can help you solve almost all the questions and it will always come out and it's definitely more difficult is this last one, which is the ultimate tool, the oxidation state. You're going to see me write this number OS here quite a fair bit. Okay, I'm going to teach you how to identify oxidation state. That's the first thing. Okay, or you can think in terms of calculate oxidation state. And then the next part is we're going to go through in terms of how to explain redox in terms of oxidation state. Now, can you please put a star here? Oxidation state is one of the most important. If you were to flip through a PYS, a lot of questions always ask about oxidation state. Okay, almost like 80 to 90% of the questions always ask about oxidation state for redox. The rest, in terms of oxygen, hydrogen, electrons, yeah, they make up about maybe the 10-20% of your other questions. Okay, so being able to do in terms of oxidation state will actually be key here. That's why I put a star. Okay, so let's look at this now. Okay, just now you realize all the reactions that we have done, okay, they are generally all ionic kind of equations. But what if they are covalent, where they are shared and stuff like this, where you can't really go and calculate electrons, and when you look at the oxygen hydrogen, it doesn't really work out that well. Okay, so the last one, which is oxidation state, this guy here works for all. Take note, all redox reaction, you can always use oxidation state. Okay, I say again, all your equations, you can use oxidation state to calculate. Okay, now, let me now go through this. Okay, so oxidation state is like the hypothetical charge if all its bonds were 100% ionic. That's why you realize oxidation state, it will be in terms of a +1, +2, or -1, -2, or 0. It feels like they are charges. It's because it is actually the hypothetical charge if the bonds were 100% ionic. Okay? So there are some rules that you need to follow. Some rules, huh? So what's the first rule? First thing, I tell you what, this one, you just write it out. I realize I write nicer. Okay, so copy this down. First part is elements. Okay? Elements. What are the oxidation state of elements? Okay? Oh, actually, no, sorry. Let's here have. Okay, sorry, rule 0. I realize the rules are here. So just cancel this one out. Cancel this one out. Okay, we will go through them in the bottom parts. Okay, rule 0. So to calculate oxidation states, let's look at rule 0. I will always start off with the rules in numerical number. So first thing, elements. As long as they are in their elemental form, that means elements not bonded to other elements. Okay, it's not a compound, right? It's an element. As long as it's an element, the oxidation state is 0. So look at this here, the Fe, iron on its own, is an element, oxidation state 0. Oxygen, O2. Now, although O is bonded to O, it is not bonded to other elements. It is still bonded to itself, right? So this one here, each oxygen, oxidation state is 0. Next one, the chlorine here, oxidation state is 0. Sodium here, 0. So as long as the elements are in the elemental form, okay, the oxidation state will be 0. So another one will be S8. Now, S8, this is obviously an element. So it's an element, the oxidation state will also be 0. So I just want to highlight that every time when you want to identify oxidation state, start from rule 0 first. Start from here. Okay, if have, good. If don't have, then never mind. Okay, but always rule out all the oxidation state with 0 first. Okay, next. Now, rule 1 and rule 2, these are when things are in compounds. Okay, this is for compounds. Ions/compounds. Rule 2 is for ions/compounds. So take note, that means it has bonded with other elements. The summation rule, can think of it as also is for ions/compounds. Okay, so elements is for rule 0. Rule 1, rule 2, rule 3 applies to ions slash compounds. So in terms of rule 1, in compounds, group 1 metals are +1, group 2 metals are +2. For example, if I got potassium iodide, Ki, what's the oxidation state of potassium here? Because this is a compound. Okay, this is a compound. Then what I have is K is potassium, is a group 1 metal. So the oxidation state of this potassium is a +1. Okay, +1. Let's try another one. What if I got Na2O? So sodium is a group 1 metal. So I use the word each sodium, each Na, the oxidation state is +1 because it's a group 1 metal. How about group 2 metal? So if I got calcium oxide, CaO, we already know that group 2 metals are +2. So the calcium here will be +2. Okay? So in terms of common metals, group 1, group 2, they are generally +1 or +2. Okay, in terms of the oxidation state. Okay, so group 1 is +1, group 2 is +2. Now, obviously, some you say, sure, then how about group 3? Okay, group 3 metals, I can only say, example, aluminium. I only want to use aluminium. Aluminium, the oxidation state of it will be +3. Okay, but anything below that, or it can go weird. Okay, so generally, you realize they only tell you group 1 and group 2, because group 1 and group 2, these are the more common ones. Group 3 can go varying. Okay, so that's why you realize group 1 and group 2 are the two main ones that's mentioned. Group 3 may not always be +3. You know what? May not always be +3. Okay. Next, common non-metals. So fluorine is always -1. Hydrogen is usually +1. Oxygen is usually -2. Now, I want you to highlight this one here. Peroxides. O is -1. So what is an example of peroxide? So if you see H2O2, this is hydrogen peroxide. This is not typo. It is not that I typo H2O, write extra 2 and oxygen. No, this is H2O2 is hydrogen peroxide. Of the oxygen here, the oxidation state is -1. In peroxide, hydrogen peroxide, the O oxidation state is -1. Okay? Now, we'll go through some examples later so that you can get a sense of how to apply these oxidation state rules. Last one, summation rule. The sum of all oxidation state in a neutral compound is 0. Okay, so for example, let's use Na2O. And the top we already mentioned, right? Now, what does the summation rule means? The summation rule means that the oxidation state of sodium plus the oxidation state of oxygen must give me the overall charge. So what you realize in Na2O, what's the charge over here? It is 0, right? In Na2O, each sodium group 1 metal +1. So I know that is 2 times +1. Okay? Oxygen, I know that it is oxygen in compounds is normally -2. So realize that my left-hand side is 0, which is also the same as my right-hand side. Okay? So the summation rule actually is to help you to do some calculation. Okay? Now, so how about if I got polyatomic ion? So I'm going to give you an example here. So example, I got CO3 2- carbonate ion. What I know is that the oxidation state of the carbon plus the oxidation state of the 3 oxygen, it must give me the overall charge, which is -2. Okay, we must give me the overall charge, which is -2. So what I'm going to do here is, I know that carbon, nothing here is mentioned. Like, it is not group 1, not group 2, it is not my fluorine, hydrogen, or oxygen, then how? So this is where you can calculate the oxidation state. So for example, in this case here, carbon, I don't know the oxidation state, but I know oxygen is -2, and the whole thing add up to become the overall charge, which is -2. So if you were to do your math, carbon equals to -2 plus 6. The carbon oxidation state here will be +4. So the summation rule is also to help with finding unknown oxidation state. Okay, so these are the rules, and we are gonna apply it. Okay, we're gonna apply it here. So let's look at this equation here. So first thing, let's assign oxidation state to all the atoms. So let's apply rule 0 first. Remember, apply rule 0 first. Rule 0 is all the elements, oxidation state must be 0. So which are elements? Elements means not bonded to any other things, right? So let's highlight in blue. So Cl2, you realize, element. I2, elements. So these two are elements, and hence the oxidation state of each atom in this element, oxidation state must be 0. Oxidation state of the each of the I over here must be 0. Okay? Can? So apply rule 0 first. Next, I'm going to apply rule 1 now. Rule 1 states that all my group 1 elements, oxidation state is +1. So I know that K is actually potassium. Right? K is potassium. It is a group 1 element. So it's group 1 element. So K in a compound, this group 1 element. So I know that K must be a +1. This K over here must be a +1. Okay. I'm going to apply now rule 2. What does rule 2 say? Common non-metal. Fluorine is -1, hydrogen is +1, oxygen is -2. Do I have fluorine, oxygen, or hydrogen? Answer is no. So I cannot apply rule number 2. But what I'm going to do is I'm going to apply rule number 3 now, the summation rule. I know that K plus I, the oxidation state of K plus oxidation of I must give me the overall charge. What is the overall charge over here? It is 0. Okay, so I'm going to apply the summation rule now. Okay, so I know that K plus I must give me the oxidation state of 0. K I know is +1. I do not know. So you realize +1 plus I equals to 0. I must be equals to -1. So the I over here is a -1. So I can apply the same thing to the KCl. So the Cl here will also be -1. Now, some of you might be thinking now, Che, why you never do anything about the 2 over here? Does the 2 affect the oxidation state? Answer is no. So you can ignore the 2. The 2 does not contribute to the oxidation state. So write this down. Balancing number / ratio number, okay, does not affect oxidation states. Okay, so you can actually cancel out the 2 over here and over here. Okay, now, so once we are done identifying and assigning oxidation state to all the atoms, we're going to identify the change. Okay, so what you realize, Cl, chlorine, the element chlorine, initially oxidation state is 0, and after that it become -1. So I'm going to draw an arrow like that. Okay, I know that the oxidation state decreased because it went from 0 to -1. So I know that because it's decreased oxidation state, this is reduced. Next, K. K is +1, after that become +1. Before and after the same, so no change in oxidation state. So don't need to talk about it. Last one, I. From -1 became a 0. So -1 to 0, this is increase in oxidation state. So this is oxidized. Now, I want you to take note, this is the working that I will always do in my question paper. Because knowing what is the oxidation state and then knowing the arrow, actually all this helped me to write my statements. Okay, so you realize the changes was mentioned here. This is actually my diagram, the arrow plus the assignments, okay, plus the writing. So how exactly to write down the statement? So I want you to put a star here. This answer is like the standard answer. So first thing I'm going to write down is that the reactant is reduced or oxidized to the product. So the before and the after, and what's the process? Okay, so I know Cl2 is reduced to KCl. So you realize the arrow that I drew on top actually helped me to write my first sentence. Cl2 reduced to KCl. Next part here, let's explain further. How do I know that it's reduction? It's because the oxidation state of chlorine. Now take note, I write this in word. I don't use the formula Cl. Okay, I use the term chlorine. So you realize I'm very specific. I did not use the chemical symbol or chemical formula here. Okay, I use the term chlorine over here. When I use the word, so the oxidation state of chlorine decreased from 0 in Cl2 because 0 in Cl2 to -1 in KCl. Okay, -1 in KCl. So this is the standard statement. Okay, I want to put here standard statement to write. Okay, so this is for the reduction answer. How about the oxidation answer? So therefore, the next one I'm going to look at Ki is oxidized to I2. So Ki is oxidized to I2. How do I know? Because the oxidation state of iodine, take note, it's not iodine, it's iodine. Okay, so this is the element. Take note, it is the element. Okay, increased, sorry, spelling mistake, increased from -1 in Ki to 0 in I2. Okay, this standard statement, please, I put 2 stars here. You must know how to write. And because there's reduction and oxidation, therefore, so let's conclude. Therefore, this is a redox reaction. Right? Therefore, this is a redox reaction. So knowing how to explain why is it redox, that's the most important thing over here. Okay? So this answer that is written there is actually the standard statement. I want everyone to be familiar with writing. Okay, so I am not going to go next page first. I want to go through a few more examples just to get let everyone get a hang of it. Let me see how can I do this. Can I add more pages? I think I should add more pages here. Oops. Is it this? Nope. This. And let me close and open again. Wait. Okay. So I'm gonna scroll up. I think I add new page. Make a blank page. Yes. Let's insert one more blank page. Okay, so I'm going to go through another example here. I'm going to go through another example here. So, okay, let's go through another redox example. So, I have, let's use something simpler. Okay, so I got zinc, Zn, plus CuSO4 gives me ZnSO4 plus Cu. Okay, so this is the equation. Then the question asked is explain if the reaction is a redox reaction. Okay, explain if the reaction is a redox reaction. So if I were to look at this particular equation, they're asking you to explain whether it's redox. I'm going to go through the same 3 steps. First one, let's assign, okay, in terms of oxidation number, okay, what is the oxidation state of each of them. So let's apply rule 0. Rule 0 is any single element that is not bonded to anything else, the oxidation state is 0. So in this equation here, do I have any elements? Answer is yes. Zinc is on its own not bonded to anything, so its oxidation state is 0. Copper over here on the right hand side, oxidation state also 0. So I'm done with my element. The next one I'm going to look at is CuSO4 and ZnSO4. Now, this one you all say, this one like damn chim here. Do I know or not? What you know is this copper sulfate. So copper sulfate, actually, you know that copper sulfate is SO4 2 minus. Sorry, maybe I shouldn't write here. Okay. So copper is, so I will try to apply rule 1 first. Rule 1 is group 1, group 2 metals, don't have. Rule 2, fluorine, hydrogen, oxygen. Okay, oxygen have. So I got oxygen here, oxygen, each of this oxygen is a -2. After that, I want to apply summation rule. But I can only apply summation rule if I know the oxidation state of each of them, right? But you realize that I got 2 unknown. I got Zn and S here. I don't know what's the oxidation state of them. So let's try to break it down a bit. So what I know is I do not know copper, I don't know sulfate, right? But you know that this copper sulfate. In this case here, you know that this is Cu 2 plus and SO4 2 minus. The idea of oxidation state is that it is actually something like the charge of the element, right? So if this CuSO4 is actually Cu2 plus, so this copper here will actually be a +2. Okay? Going on, I got SO4. So I know that looking at here, I'm going to break this down further. I know 1 sulfur, so I'm going to break it down now. 1 sulfur plus 4 oxygen in terms of the oxidation state, it must give me a -2. Okay? So I know that sulfur is a question mark to me. I know that each oxygen is a -2. Each of the oxygen is a -2. So 4 times -2. This must give me a -2 overall charge. Okay? So if I were to do my math, I realize S is a +6. So this sulfur here is a +6. So I'm going to apply the same thing over on this side. So I know that this sulfate, so I know zinc is a Zn2 plus. I know it's a SO4 2 minus because it's a sulfate. So I know that this, because it's the same sulfate, it'll be a +6 over here. I know Zn2 plus. I know that this will be a +2. Okay, so assigning the oxidation state is the first step. Most students will always lack of practice and they cannot do the oxidation state quickly, or they struggle with doing the oxidation state. So being able to do this is key here. Now, so once I've assigned the oxidation state, I'm going to look at what's the change. So I know that sulfur is +6 to +6. I can ignore sulfur. Okay, I just ignore sulfur. Oxygen -2 to -2, so I just ignore. So I know that zinc got changed. Zinc from 0 become a +2. So this increase in oxidation state. So this oxidation. Next one, copper from +2 becomes 0. I know this is a reduce in oxidation state. This is reduction. So I'm going to write the answer now, the statement, how to explain if it's a redox. So the answer will be this. Zn is oxidized to ZnSO4. Okay? So the reactant, what's the process that happened to it? The product. How do you know it's oxidized? It's because the oxidation state of what element? Of zinc. Okay? Increased from 0 in Zn to plus 2 in ZnSO4. Okay? So you realize this statement looks exactly the same as the one that we did before, because that these are the things that were changed, right? In terms of the these parts that underline are the ones that I've adjusted to fit this particular question. Next, I'm going to write is the reduction sentence. So I'm going to write CuSO4 is reduced to Cu. Okay. Why is it reduced? It's because the oxidation state of copper decreased from plus 2 in CuSO4 to 0 in Cu. Okay, those that are underlined are the things that I have adjusted accordingly. Okay, so this haven't explained finish yet. So I say there's reduction, there's oxidation, therefore must conclude. Hence, this is a redox reaction. Of course, you must always conclude, right? Okay, they ask, explain if it's a redox, you say yes in the end, this is a redox reaction. Okay, so this is one of the reaction to just take note of. Okay. Any question? Any questions so far? If all okay, can you all please thumbs up? Okay. Now I want to do one more question. Okay, I want to do one more question because this question here involves KMNO4, which is also a good one to have. Okay, so let's do one more question since I got one more blank page as well. So we're gonna look at another equation here, which is MnO4 minus whatever this thing is, plus Fe2 plus, how many of them? 5, plus 8 hydrogen ions, gives me Mn2 plus 5 Fe3 plus 4 H2O. Okay, so I mostly want to use this is because the application of the rule, a lot of students will make common mistakes over here. So let's start. Let's apply rule 0. Okay, rule 0 says that if any element, it will be oxidation state 0. Now, the thing here is, isn't iron here an element, hydrogen element, Mn element, Fe element? Now, answer is no. Because why? Do you realize that they're actually charged? If they are charged, means they actually bonded to something else. It's just that this is an ionic equation. So because the ionic equation, the spectator ions are removed. Okay, therefore, because the spectators ions are removed, you don't see what it is bonded with others. Okay. Second thing, how do you know that they are not oxidation state 0? Is because you realize they all have charge. They all have charge. If they all have charge, means that they cannot have oxidation state 0. Because why? Remember, oxidation state is something like its charge. So therefore, I cannot apply rule 0 here. Let's apply rule 1. What does rule 1 tells me? Rule 1 say any element in group 1 or group 2. Look through all of this. None of them is in group 1 and group 2. Skip. Let's look at rule number 2. Fluorine, hydrogen, oxygen. So I got no fluorine over here, but what I have is hydrogen and oxygen. So oxygen here bonded to Mn. Each of these oxygen is a -2. Hydrogen over here, you realize it's bonded to something else, but I don't know what it is. But you realize hydrogen here is a +1, right? Because plus charge. Next one, hydrogen here is a +1, each of them. Oxygen here, each is a -2. Okay. Okay. So this is the after applying rule 1 and rule 2. Now, then we're gonna do the summation rule. Okay, summation rule is you're gonna add the oxidation state of all the elements, you must give the overall charge. So let's look at MnO4 for example. MnO4 minus means that I got 1 Mn plus 4O, it must give me -1. Okay? Mn plus 4O must give me -1. This is the oxidation state. So Mn, I don't know. But I know each oxygen is -2. Okay, each oxygen is -2. Overall charge is -1. So therefore, if I do my math, my Mn will be -1 plus 8, then it will be a +7. So the Mn here is a +7. Okay, +7. Now, iron, Fe2 plus. A bit lame, but actually, there's only Fe and the overall charge is 2 plus. So actually, the Fe here is a +2. So I can do the same thing here. The Mn here must be +2. The Fe here must be +3. So realize I use the summation rule to know that the Fe is a +2. But the other way is also to say that whatever charge it is, then that must be the oxidation number, right? Because oxidation number, oxidation state is the charge of the particular ion or the particular substance also. Okay? So there's a few ways to look at it. Now, so with this in mind, we are now going to look at whether there's any change. So let's look at Mn. Before and after, from a +7, it became a +2. So I know that this is a decrease in oxidation state. So decrease in oxidation state is a reduction, reduced. Oxygen -2, after that also -2. No change, so I can just ignore. Next, Fe2 plus. You realize the 5 here, I don't care about it because why? These are the balancing number. Don't need to care. Just focus on the oxidation state. +2 to +3. Increase in oxidation state, so this is it, oxidation. Okay? Last one, hydrogen +1, after that also +1. No change. So actually we have identified what is reduced and what is oxidized. So let's write out our answers here. So the answer here will be, let's start with MnO4. MnO4 minus is reduced to Mn2 plus. That's the first statement. The second statement I'm going to write is the oxidation state decreased. Sorry, let's write in words. Decreased from +7 in MnO4 minus to +2 in Mn2 plus. So those words to take note of. Sorry, now I realized I missed out one word. My bad. Okay, there's supposed to be a word here. The oxidation state of manganese. Okay, not manganese, manganese. Okay, decrease from +7 in MnO4 minus to +2 to Mn2 plus. So what's the element Mn is manganese. Okay, so this is in terms of reduction. I'm going to look at oxidation now. Fe2 plus is oxidized to Fe3 plus. Okay, so I've already written down. So the next sentence will be the oxidation state of iron, okay, increased. So the element is iron, right? Increased from +2 in Fe2 plus to +3 in Fe3 plus. Okay, so underline all the words that I have adjusted from the template. Okay, and you realize that, okay, I'm almost done already. Just need to finally conclude. Hence, this is a redox reaction. Okay, so this is another question. So you realize that applying the rules for oxidation state is always the first part, and then after that, explaining it is the second part. If you're able to do these two well, you're more or less safe already. Okay, so when school reopen, I'll be giving you the assignment for redox. So that's where you will get a chance to practice these questions on how to explain. Now, of course, question is, if this comes out, how many marks will it be? Do one is so tedious. This whole thing here can be worth 2 to 3 marks. Okay, I say again, 2 to 3 marks. Okay, so just take note in terms of the overall writing and stuff. If it comes out, this is actually like the free marks that you must get one, because it is once you get a hand, it's like a machine, right? You go through the process, you do the whole thing, sure get correct one. Okay. Now, so let's go through the last part already. Oxidizing agent and reducing agent. Now, so we look at redox in terms of reduction and oxidation. So what exactly are oxidizing agent and reducing agent? So reducing agent is the substance that causes the oxidation. In doing so, it gets reduced. Okay, sounds confusing, right? Okay, think about it. Let's look at this question here. Okay, do you realize that in this question, I have zinc and copper sulfate? Okay, zinc and copper sulfate. There's only 2 things that are reacting only. 2 things. Zinc. Sorry, I'm going to use a different color. Zinc and copper sulfate. Okay, there's only these 2 things that's reacting. So then the question is this. I know that zinc is oxidized. Now, zinc cannot be oxidized itself, right? Okay, something must have oxidized it. So if zinc is oxidized, the only thing that can oxidize it is CuSO4. Because only got these 2 things, right? If zinc is oxidized, that means CuSO4 must be the one that's oxidizing it. That's why CuSO4 is the oxidizing agent. Now, in my question, I also know that I written down CuSO4 is reduced. So some guy must have reduced CuSO4, right? In this case, only got these 2 reacting. So therefore, zinc must be the reducing agent that has reduced CuSO4. Okay? So this idea of reducing and oxidizing agent, it always comes as a pair. Okay? It always comes as a pair. When something is oxidized, okay, let's say A is oxidized, B must be the oxidizing agent that has oxidized it. If B is reduced, A must be the reducing agent that has reduced it. Okay, so in that idea, along that idea, okay, the oxidizing agent is the thing that causes oxidation. In doing so, itself get reduced. The reducing agent is the one that causes reduction. In doing so, itself get oxidized. Okay, now, so if we look at the previous question, Cl2 and Ki, Cl2 was reduced. Cl2 is reduced. Who reduced it? Ki, correct? Because only got Ki reacting Cl2, right? So Ki is the reducing agent. Ki is oxidized. Who oxidized it? Cl2 must be the oxidizing agent. Okay? The other way to look at it is whatever is being reduced is the oxidizing agent. Whatever that's oxidized is the reducing agent. I think this way of explaining it is a bit confusing. Okay? So that's why I always look at it in pairs. I am always able to identify what is oxidized, what is reduced. And then from there, I ask the question, who oxidized it? I ask the question, who reduced it? And then it will become easier to explain the whole thing. Okay? Now, later on, I'll work out one more question after this. Just want to cover this last part. Okay, so I want to test for oxidizing agent. Okay, I want to test for oxidizing agent. So for example, I got A, substance A over here. I want to know, is it, sorry, I got substance A. I want to ask, is this an oxidizing agent? Now, to be able to test that it's an oxidizing agent, to be able to test that it's an oxidizing agent, what should I add to it? So to test oxidizing agent, I will reducing agent because it comes as a pair. Okay. To add oxidizing agent, to test for oxidizing agent, I'll add reducing agent to it. If there's a reaction, then I know that this is correct. Okay. So to test for oxidizing agent, I'm gonna add potassium iodide. This is a colorless solution. Right? This is a colorless solution. It is a reducing agent. So I want you to take note. Ki potassium iodide is a reducing agent. Remember this. Okay. So after I add potassium iodide, it's a colorless solution. If okay, substance A is an oxidizing agent, my solution will turn from colorless to brown. So if I see potassium iodide added, the reaction is colorless to brown. It tells me that oxidizing agent is present. Okay, so why is it that it will turn from colorless to brown? So what is actually happening is that potassium iodide is actually colorless, but the oxidizing agent caused my iodide to become I2. So this is colorless ion. This is actually a brown solution. So because the I minus become I2, that's why my solution turns to brown. Okay, the iodine molecules dissolved in water is a brown solution. Okay, so Ki is there to test for oxidizing agent. It will turn from colorless to brown if oxidizing agent is present. Okay, so Ki, if you want to write down, Ki is used to test for oxidizing agent. Write it down. It will turn from colorless to brown. Okay, if the oxidizing agent is present. Okay, so this whole slide here, this is the key point here. Okay, and of course, take note, Ki itself is a reducing agent. Okay, so 3 points here. Ki is the reducing agent. It is used to test oxidizing agent. It will turn from colorless to brown. Okay, for a positive test. Next one, I'm going to test for reducing agent. So to test for reducing agent, so now I use BR. So B, how do I know that it is a reducing agent? Is it a reducing agent? Question mark. So to test for reducing agent, I must add oxidizing agent. Okay, I must add oxidizing agent. So what is this test here? The test itself is to add purple acidified. Okay, sorry, don't even need to use the purple. Okay, what is the thing itself? It is acidified aqueous potassium manganate 7. Or sometimes you say acidified potassium manganate solution. Right? This guy here is an oxidizing agent. So what's the result? It will turn from purple to colorless for positive test. So how do I know what really is happening? So what's happening is actually the MnO4 minus, this guy here is actually purple in color. It is actually getting reduced by the reducing agent to Mn2 plus, which then becomes which is a colorless ion. Okay, so because of that, what you realize is that if I know the solution changes from purple to colorless, it is a reducing agent. Okay, so just to wrap up for this one over here, okay, acidified. So I realize you realize this one I propose you acidified KMnO4 solution. Okay, is an oxidizing agent. Okay, first sentence. Second sentence is Okay, so I want to follow the same thing. All right. It is used to test for reducing agent. Third point, it will turn from purple to colorless. All right, it will turn from purple to colorless. So this is the key point in terms of whatever that is mentioned in this particular slide over here. Okay, and just a general idea of what we have gone through in terms of reduction, oxidation. So we went through these four ideas, and then the last part is we went through the idea of oxidizing agent, reducing agent. Okay, and oxidizing agent, we know is KMnO4. Reducing agent is Ki. Okay, those are the things that we have gone through in terms of the general idea for this particular slides. So, in terms of all this, I just want to highlight this one, practical skills. You actually realize that redox come out in your practical for titration. Okay, so titration, important for redox. It's not just only for your titration. Actually, in terms of QA, they can also test you on it as well because there's a color change. Okay, now for you to do well in exams, please remember the template, especially for oxidation state explanation. Next thing, also please take note of the oxidizing agent and the reducing agent. What are the two? And then what is their color change? Color change. Okay. So in the last 15 minutes, okay, of this particular session, I just want to add in two more blank slides. Let me press done here first. Let it save just in case anything happens. I'm going to reopen this. I'm going to scroll down all the way to the last slide. Okay, I'm going to add new slides. Insert blank page. Insert blank page. So let's look at one of the reaction over here. Let's try this one. Okay, because I want to show you oxidation state and reduction. Oxidation state explanation with the idea of reducing agent and oxidizing agent all together in one question. So let's look at this. Mg plus HCl. It will give me MgCl2 plus H2. Let's balance it like that. Okay, so this is the acid plus metal reaction. Okay, we're gonna apply. So the question is it redox? Question mark. What is the reducing agent? So this question here, let's practice by saying, let's explain whether is it a redox reaction. Secondly, if it is yes, what's the reducing agent?
But
So
I'm
we're
fucking
gonna,
lost in though. Wait, like,
please mute yourself. Mute yourself, don't know what you're doing there. Okay, anyway, let's carry on. Okay, so apply rule 0 first. Any element first. Okay, any element. Mg here is an element, so 0. Oxidation state, element here, 0. Each hydrogen there, 0. So done. Next, I'm gonna apply rule 1, which is group 1 metal or group 2 metal. So no group 1 metal in HCl, no group 2 also. I got Mg here. So Mg is a group 2 metal. So I know that the Mg here must be +2. Next, for non-metals, I got no fluorine, I got no oxygen, but I got hydrogen. The hydrogen here bonded is +1. Okay. Then nothing else left, right? So time to do in terms of the summation rule. Now let's go for the final rule. So I know that I ignore the balancing number. I know that the H oxidation state of my H plus my Cl must give me the overall charge over here, which is 0. I know H is +1. I do not know Cl. Hence, if I calculate here, my Cl must be -1. So this Cl here is a -1. Okay, let's try on this one. oxidation state, summation rule, Mg plus 2Cl must give me overall charge, which is 0. Mg I know is plus 2. I know that there's 2Cl over here, which I don't know what it is. Okay, then after that, if I were to do my math, my Cl here will be -1. So this here, -1. Alright, so I calculate out the oxidation state already. Now time to decipher which is reduced, which is oxidized. So Mg from 0 to +2. So this is an increase in oxidation state. So this is oxidation, oxidized. Cl, no change. H from a +1 to a 0. So you realize that this one is a decrease in oxidation state. So this is a reduction, reduced. So time to write the answer here. So the answer will be Mg is oxidized to MgCl2. Okay. How to explain this? The oxidation state of magnesium, okay, increased. All right, increased from 0 to 0 in Mg to +2 in MgCl2. Okay, so that's the first one. Second one will be HCl is reduced to H2 because the oxidation state of hydrogen decrease. Okay, it's decreased from +1 in HCl to 0 in H2. Okay, so this is this is in terms of explaining the redox. So question is, what is the reducing agent? Okay, so question is, what is reduced? HCl is reduced. So this guy here is reduced. Now, there's only Mg reacting with HCl. So if HCl is reduced, who or what substance reduced it? So therefore, I can conclude Mg is the reducing agent. Okay, because HCl is reduced, something must have reduced it. What's the something? It is one of the reactants that have reacted with it, right? So therefore, Mg here is the reducing agent. Okay, I'm gonna do one more question, the last question before we wrap up for today. Okay, let's look for one more redox reaction that's common in your syllabus. Okay, let's try let's try a Ki reaction. So Ki. Okay, so I'm gonna have Br2 plus Ki. This will give me KBr plus I2. Okay, let's balance this. So I'm gonna apply the rules now. I'm gonna do a bit faster now. Okay, so just take note. Rule 0 applied to here. So bromine, iodine, both in element form. Group 1 element, potassium. Group 1 element, potassium. In terms of I and Br over here, I do not know what they are. I'm going to use a summation rule. So I know that the oxidation state, K plus I must give me 0. Okay, because overall charge is 0. Therefore, I know K is +1. I do not know. Overall charge is 0. I will become -1. Do the same thing over here. K plus Br equals to 0. K is +1. Br I do not know. Okay, overall charge 0. Overall charge 0. So Br will also be equals to -1. So -1 for this, -1 for this. Realize I do not touch the balancing number. I do not touch the ratio number. Okay, in oxidation state and calculation, you don't care. I'll repeat, you don't care about the oxidation, or you don't care about the ratio number / balancing number. Okay, so now when this is done, you can just straight away go and. Okay, so this one, the question is it redox? Yes, question mark. What is the oxidizing agent? Okay. And I'm going to add on in terms of what will be the observable change. Question mark. Okay, so redox first. Let's settle the redox. So this one I know Br2 became KBr from 0 to -1. So the decrease in oxidation state. So this reduced. Ki, the I from -1 became 0. So there's an increase in oxidation state. So this oxidized. So therefore, I can write my sentence now. Br2 is reduced to KBr. What happened? I'm going to write short form now. The oxidation state of Br or bromine decrease from 0 in Br2 to -1 in KBr. Okay, so that's the first sentence to talk about what is reduced. Next one, I'm going to talk about oxidation. So Ki is oxidized to I2. So the oxidation state of iodine increase from -1 in Ki to 0 in I2. Okay, so this is the hence redox reaction. So I mentioned the first part already, so I'm done with the redox part. Which is the oxidizing agent? So I'm going to ask myself, what is oxidized? This guy here, Ki is oxidized. So what oxidized Ki? Ki only reacted with something, only one more thing, right? So Ki is oxidized by Br2. Therefore, Br2 is the oxidizing agent. All right, oxidizing agent. Now, what is the observable change? What do you realize I added? Potassium iodide. I know Ki is a reducing agent. I know that when it reacts with something else, it will turn from colorless to brown. So therefore, the Ki solution will turn from colorless to brown. Okay? So you realize I expanded the question bit by bit, adding a little bit more stuff, but this is the max, most probably they'll ask you already by adding the last observable change that can be included. So actually, this is all for the chapter of redox. Okay? If you go and see the questions in the assignment, you can see the questions in TYS, it will always be similar to this kind of explanation. So my suggestion is, once you're done with this, can I just ask you all to go and within the next today, just try one question in redox. 2 days or 3 days later, try another question on redox, just to make sure that you have internalized the questions. Or internalize how to go about applying it. You realize I breezed through my oxygen, hydrogen, electrons, that segment, because those few seldom really come out. The one that really comes out is oxidation states. Next one, oxidizing reducing agent. And the last one is being able to explain in terms of this whole increase, decrease, what's reduced, what's oxidized. Just want to highlight, take notes, put a star, remember the template. Practice the template. Okay, practice the template. Okay, so that's all from me. Okay, if nothing else, that's all. Bye-bye, guys. See you.